What's going on, guys? Welcome back to the channel Physics Nowhere, and today we have a banger of an episode for you.
Have you ever wanted to set off fireworks but you were too scared because they were going to explode in your face?
If you said yes, then this video is perfect for you.
Because in today's tutorial, we're going to demonstrate how to set off a Rube Goldberg machine to set them off.
And without further ado, let's get right into it.
Woo!
Everyone, thanks so much for watching.
Don't forget to like and subscribe. See you in the next one.
Peace. Just kidding, that would be way too short a video to get 100%.
Let's keep going with more detailed explanation.
So the project started off by tightly tying a strong string to a brick. The string was then hooked onto the garage door. The brick was then placed on a table, protected by a towel, and the basketball was placed in front of it. Later on, the string will be attached to a car so that when the car rolls forward, the brick will knock this ball down the ramp. The ball will then land in this bucket, which we attach clamps at the back to prevent the ball from rolling away, and some coffee tins in the center for the ball to remain the same height as the edges of the bucket. The next thing to do was begin the construction of the kicking shoe. So we shoved a shoe inside of a glove on a wooden block to create the kicking function, drilled a hole in the side in order to insert a bolt so that the wood can move in a circular path, and then we ran into our first issue. How are we going to attach the kicking stick to our project? Well, the answer was simple. We created a massive wooden beam. So the beam was made. We took some measurements in order to see how high we needed to raise the beam, and then we made this A-looking structure to hold the beam higher. After that, with a little bit of holding support, a mess was made with holes being drilled and bolts being screwed between the beam and our wooden sticks with the shoe on it. So now we had to figure out a way to actually get the shoe to release once the basketball went inside of the bucket. We held down one end of a string by the 70-pound plate. The spring then went over the bucket, which I should mention that we added a piece of cardboard so that the basketball didn't hit the lip of the bucket after it was kicked. Then went under this fancy looking machine and it attached to the shoe. Luckily, the shoe was able to easily rest beside the wooden beam we built because of friction, so we didn't have to create anything extra here. So once again, the basketball is going to roll into the bucket, land on the cardboard attached to the string, and then the string will fold in, triggering the shoe to release and kick the basketball. Here's a pretty nice view of what we have so far. Now we needed to build something for the basketball to hit after it was kicked. So the first step was to create a base so that it could lie flat on the floor. Then the head was created, which we just nailed a larger piece of wood on the top. And then we burned the wood. Here you can see more wood blocks being placed to make a pathway for the volleyball to roll after it gets knocked. This is where we put the piece of wood right on the 70-pound plate and it is lined up perfectly so that the basketball and volleyball are in line with one another, as well as with the shoe's path. Now that this was all working, the next step was to create the space for the hairdryer on wheels to roll on. We thought of a much better and easier solution to do this, so we just put a couple hundred little copper balls for the hairdryer to roll on. The hairdryer was then taped to yet another piece of wood on the bottom, and a piece of wood was nailed on near the bottom of the hairdryer to make a flat surface, so that these wooden blocks could fall down after the volleyball hits them and make the hairdryer move at a higher speed. Now you may be wondering, there was a ping pong ball on top of the hairdryer that wasn't talked about yet. Well, look at this. A plinko board is being built for the ping pong ball to travel downwards after the hairdryer reaches the end of its little path. We just hammered a bunch of nails to a piece of wood and then put some cardboard on the outside to create a funnel, so that the ball ends up in the middle of the board every single time once it reaches the bottom. But then, we ran into two more issues. The ping pong ball wasn't heavy enough to release the drone attached to the string, and sometimes the ping pong ball missed the plinko board entirely because the hairdryer had too much speed. These were easy fixes, however. We just put some cardboard with paper and tape at the top of the plinko board to slow the ball down, and then instead of the ping pong ball cutting the string, it will just hit these golf balls, which by the way are much heavier, so that they can do the string cutting. Here's what this section is looking like, and here's what the whole design is looking like at the moment. Now this is where things begin to get interesting. Our design changed a slight bit from the start of the project. We were initially going to use a toy car to go up a ramp, but then we thought it would be easier to just fly a drone upwards in order to flip the piece of wood to pop the balloon. So we started out by putting this metal tube under a hockey bag, which will act as a balance. Then the fun begins. A drone was attached to a string and placed on this piece of wood with cardboard stapled onto it. So now that they're attached, when the drone flies up, so will the entire piece of cardboard and the wood will flip. On the other end of the wood, we hammered in ever so carefully a sharp nail. The next step was to create a funnel for marbles to roll down, which we made by cutting a hole out of this empty plastic container. This table was perfect for the job, as it held the funnel into place as well as had a pipe on the other end. Then a balloon was blown up with several marbles on the inside and was placed on top of our funnel. If you can't see, the nail will pop the balloon, causing the marbles to roll into the pipe below the funnel. Speaking of pipes, we attached a longer pipe to our existing pipe. We cut a gap in a piece of wood in order for the pipe to be able to rest in it while still being above the ground. Before and after. Wow! But the fun doesn't stop there. Take a peek at this nifty looking contraption. A baseball is going to roll down all of this wood. We put cardboard at the end of every wooden plank so that the baseball wouldn't fall off. But how does the ball even start rolling, you may ask? Well, we put half a plastic water bottle on a string at the bottom of the tube. The string is attached to a nail wedged in a hole at the beginning of the baseball's root, holding the baseball back behind it. Once the marbles roll into the plastic water bottle, the nail drops down and releases the ball. After the ball rolled all the way down onto the floor, it knocked over some dominoes. Look at these little guys. They kept falling down over and over again and probably wasted a solid 2 hours. The dominoes tumbled down, eventually hitting these wooden blocks and textbooks, acting as bigger dominoes. Once the physics textbook hit the door, this Powerade bottle fell off, triggering the zipline. Before we talk about the actual zipline itself, let's take a moment to appreciate the time spent making the zipline trolleys. Holes were cut from small pieces of wood, then bearings from our favorite fidget spinners were taken off and screwed inside with some washers, and a hook was put on in order to easily attach these to the actual zipline. We also taped on some bolts to add some additional mass to the trolleys. This helped them go down the zipline a lot easier. Alright, so here's the zipline. The Powerade falls off the door and the first zipline trolley is activated. Here's what it looks like from trolley 1 to trolley 2. Trolley 2 will go down the middle of the backyard to activate the fireworks. A stake was put in the snow to mark the end of the zipline's journey. This also helped it stay in the air. But one more structure needs to be built first: the firework platform. Some nails were hammered into the bottom of this platform to keep them in place, and then the blowtorch will be put at an appropriate distance so that it can ignite the fuse. A metal sheet was placed directly between the torch and the fireworks, which was tied to a wad of string. When the string is hit, the metal sheet will drop and the fireworks will light. Here's one last look at the final platform after we put it all outside.
And now that you know how we built the project,
Here's a detailed walkthrough of how each and every step of the project is going to work.
So the car will drive down a hill after a slight push due to its gravitational potential energy, and the cinder block will then swing and contact the basketball since it wants to return to the equilibrium of the pendulum. The basketball will roll down, transferring its gravitational potential energy into kinetic energy and land on this piece of cardboard, which has a string underneath. This shoe will be up here attached to the string. When the basketball lands on the string, it increases the tension just enough to where the string gets pulled from between the wood beam and the shoe. This slight motion allows the force of gravity to overcome that of friction, the only thing holding the shoe in place. The shoe will fall and gain momentum and kinetic energy, which is transferred when it kicks the basketball into this piece of wood, which will then collide and transfer some energy to the volleyball so it can roll, ricochet off the wood in a 2D collision, and allow a domino effect to occur. The wooden dominoes will transfer their kinetic energy, which started as gravitational potential energy, to the hairdryer, and it will roll across the table on small copper balls, which reduce the friction between the two surfaces, allowing it to maintain the necessary speed to ensure the ping pong ball goes into the cardboard, but also ensuring it is slow enough so that the ball does not fall off along the way. It will then reach the wooden stopper. A piece of cardboard will cut off the upward force on the ping pong ball, and it will fall due to gravity into the plinko board. The ping pong ball will collide with a couple loosely placed golf balls, and all the balls will make their way down the board with the help of gravity. Ping pong and golf balls continue to roll down the plinko board and eventually transfer their energy into another small piece of wood, which, when moved just enough, allows the drone to fly towards the ceiling, causing the piece of wood to which the drone is attached to rotate. The opposite side of the board with the drone is fashioned with a sharp nail, which, with the extra speed and energy provided by the drone, will hit a balloon with marbles in it. The nail will puncture the balloon, and because of the balloon's elastic nature, it will shrink to its regular size, and the marbles, which are inside of the balloon, fall due to gravitational potential energy into a funnel, then through two metal tubes. The marbles are dropped into this plastic water bottle, causing an increased mass, and therefore a greater force of gravity acts on the bucket. Because it is only held up by the friction of a nail in a specifically angled hole, once enough marbles land in the bottle, the nail's friction with the wood is overcome and it falls out of the bottom. The nail drops to the ground, and the baseball, which is positioned behind it on the angled platform, falls due to the force of gravity acting on it. The baseball travels down the contraption until it finally reaches the ground, where it transfers its energy into a pile of dominoes through a collision. The dominoes continue the chain reaction, which eventually leads to larger and more massive dominoes. In this case, we use textbooks, and this is the most they've been used all year, by the way, in order to be able to move the door. When the smaller dominoes impact the larger ones, they will fall into the door, causing the door to open up wider. The opening of the door knocks a Powerade bottle, which is hooked up to a string, off balance. When the Powerade falls, the gravitational potential energy is transferred to kinetic energy, which is enough to pull a knot tie in front of the first trolley on the zipline loose, putting the zipline trolley in motion. Once the first zipline trolley reaches the end and has gained enough speed with gravitational potential energy transferring into kinetic energy, it will knock over a piece of wood set up on an even smaller piece of wood, which will cause a slow falling effect and also allow us time to catch up with the cameras. This slow falling piece of wood will transfer its energy directly into the second zipline, which is lodged in place due to the friction of itself, and the surfaces around it. The second trolley will then make its way all the way down the zip line, again due to the gravitational potential energy. Once at the bottom, it will have enough speed and momentum to knock a roll of wire and a metal plate out of the way. This will also take out the metal sheet which was preventing the fire from the blowtorch from lighting the fireworks. Once this is done, the fuse will be lit and the fireworks chemical energy transfer can begin and will be set off, all in time for New Year's.
And now, for the moment you've all been waiting for.
The final result. Well, that concludes today's episode of Physics Nowhere.
I hope you learned something useful.
Don't forget to like, comment, and subscribe, and we'll see you in the next one.
And remember, physics where?
Physics Nowhere!
Nowhere.